All right, Module 4, Lecture 2, EGN3613 Engineering Economics. I'm your host, Dr. Ron England. We got a few more oddball examples, unconventional equivalency calculations. Actually, I wouldn't call them unconventional. They're actually quite conventional. Essentially, they all follow the same rules. You're going to calculate an equivalency, and you're going to figure it out from there. So what are some other things that can happen? Well, one of the things that can happen is you can have cash flows that change. You have so much for a certain period of time, and then it changes to another amount. What kind of cash flow does this? Well, salaries, you get a raise and you get more, or you change jobs and you get more or less. How do you deal with this situation? Pretty straightforward. This is just the sum of, well, this is just the first one here is just the basic interest equation to get the present value. Then you can use the annuity equation, the series equation, to get these three, and then these four, and then this one with the interest equation, and you simply add them all together. Not too hard. Okay? Again, equivalence. It's that simple. Okay? What about another question here where you say, if we deposit $100 a month or a year, let's just use years, for 4 years, how much can I take out in years 5, 6, 7, and 8? Well, first, that's probably more than $100. You're going to get some interest there. At 10% interest, it should be pretty good. So what could this be? Well, let's just simply, there's actually a few ways you can do this. Interest rate of 10%. What can we do here? Well, let's just calculate the value at a specific point of time of 1. And in this case, we're going to have to actually solve for A. We're going to solve for the amount. But if we have it in terms of a value at a fixed point in time, that's really not that hard to do. So you could do this at time period 0, and then go back and calculate using the annuity equation for A at 5, 6, 7, 8, 5, 6, 7, and 8. Okay, well, that's not terribly hard. Okay, I'm going to leave this up here for a second because you will want the numbers, because what I expect you to do is to do this. I expect you to do the calculations, either by hand or with a spreadsheet to get this, and see if you get the same number. But the concept is not terribly difficult, or you could calculate the equivalence at time period 4. Okay, doesn't matter, it's going to give you the same value, right? Now, you can do it by using the factors and then just solving, like in this case, solving for A here, the A which being the years 5, 6, 7, and 8. But essentially, it's just looking at an equivalence. I mean, really, not that hard. Now, what about if you have different interest rates over time? Well, again, you just calculate them individually. You don't have to do it individually. You could do it with an annuity at specific, well, in this case you can't because it's not a series, but you just adjust for the specific interest rates. But look, the $300 actually changes at time 1. From 1 in year 1 to 2, you've got it at 5% for one, at 6% at another. How do you do that? Well, one is you can take the 1 and put it at time 2, and then take the and you can move them up for the individual interest rates one at a time, right? So just do it one at a time. Take the $300, calculate it at time 1, then move it to time 2. Now you've got another value at time 2, $500 you're going to add to it. Whatever that 300 was at time 2 is going to get added. Okay, so it's going to be more than 300, or it's farther away, so it's going to be less than 300, but it's going to be added to the 500. And now you're going to move that to time 3 with the 6%, and time 4 with the 4%, and now add in that 400, and then you get the future value. That's it. It's pretty straightforward. Okay, I hope that that looks to be relatively straightforward. The 300, well, actually, the 300 at 5%, you can just calculate by hand. Okay, 5% of 315. And then at 6%, you can add, so, but anyway, it's really not that hard to do. You move the 315 up in time with at 6%, you add the 500, voila. I'll leave those calculations up there just so you can work through them, but it should make sense. Okay? So you can deal with multiple interest rates and multiple amounts at the different interest rates over time. Ooh, the missing payment. What do we do about the missing payment? Well, there's actually a lot of ways you can deal with the missing payment one. Okay? The easiest is simply go ahead and make it a series, put the $100 in at time 10, so the series is there, but now you have to offset by having 100 in the other direction. So now you only have to do two calculations. You do the calculation for the series, and you do the calculation for the $100 that you put in the opposite direction. You're basically going to subtract that out. Voila. Okay, so basically now you've got two calculations to do, and you put them in, and voila, you've got the present value. It's all equivalence. Ooh, a fun one here. How about having an annual interest rate, but payments made every other year? All right, well, how will you approach this one? Well, one of the things that you could do is you could take that C, that every other year payment, and calculate what it would be as an equivalent of two payments. Then you would have an equal payment of each of those over every single year. Modify it to be A. And in the case here, it's easy to calculate with the initial value of 10,000 what that A would have to be. Okay, 1357.46. We need to get that now to an every other year type of situation. But then again, that's not that hard because you've got the A and the A. You know what that annual would be there. Okay, C is not going to be just the two A's added together for each of the 2 years because remember, one of them is offset in time, but it's only offset by 1 year. So that's a pretty straightforward calculation. Okay, boop, you move it over and voila, you calculate the C and that's it. There you go. Now, one of the ways that you could look at this one here, which is another way to look at this, because you can have a little bit of a very interesting situation, but it's a common situation that you don't have payments on the same period as the interest rate. Okay, so what does this actually mean? Well, this is 14 periods at a 10% interest rate with only 7 payments. But the reality is that there would be an equivalent interest rate that would be a 2-period interest rate. That would not be 10%, however. It would have to be something greater than 10%. So you can calculate for that specific, and in this case, the equivalent interest rate you can calculate to be 21% for those, which that one is a relatively simple calculation because now you just take it to be a series with a known present value, and you know what the value of C is because you calculated it earlier in the other one, and you can just calculate for an equivalent interest rate. See? Not that terribly challenging. So all of these scenarios are simply scenarios that you are capable of figuring out. Okay, you've got the tools to do all of these. Remembering that you just got to get it to the concept of equivalence. Okay, and don't worry, As people said, with Dr. Eaglen, if he hasn't covered it in the lectures, he'll make sure he covers it in the exam. Doesn't matter. You're prepared. I can throw curveballs at you. You'll figure out how to hit them because you know the concepts of equivalence and you know the basic equations to work with. So really, you are prepared. If you understand these concepts, you're prepared to do any time value of money types of calculations that we might throw at you. So on out. Have a good day.